Unit 2, Section 5. In this unit, we're going to be talking about compound inequalities. Compound inequalities are also known as double inequalities, and they are two inequalities that are joined together by one of two words, either the word and or the word or. So let's talk about the difference between those two. The intersection, which is known by this symbol here, it looks like an upside down U, is the graph of a compound inequality that is joined by the and. It represents the intersection or the overlap of the two inequalities. So think of intersection or overlap where these two inequalities or what they have in common. All right, so let's look at example 1 here. I want all of the x's that are greater than 4 and all the x's that are less than or equal to 8. So if we were to graph these two inequalities separately, all the x's greater than 4 would be an open circle here at 4 and everything to the right. And all the x's less than or equal to 8 would be a closed circle here at 8 and everything to the left of 8. Now, if we want to graph the overlap or the and part of that, we want to graph what they, or their intersection, we want to graph what they have in common. So if we were to merge these two graphed inequalities together, it would be an open circle here at 4, everything between 4 all the way to 8, and then it would be a closed circle at 8. So in the end, my actual solution here for this compound inequality is the graph of an open circle here at 4, everything to the right, and a closed circle here at 8. That is the graph of an intersection. Let's take a look at a graph of a union symbol, or two inequalities that are joined by the word or. So the graph of a compound inequality with or the union, also known as the both of these, are the graph of both inequalities at the same time. So example 2 shows the union of all the x's less than -3 or all the x's greater than or equal to 5. So let's start off by graphing these two right away. All the x's less than -3 would be an open circle here at -3 and everything to the left. And then all the x's greater than or equal to 5 would be a closed circle here at 5 and everything to the right. So when we say or, and we want to graph the or of these, then what we're doing is we're graphing the union, or we're graphing both of those inequalities on the same number line. So really, the solution to this compound inequality is exactly the graph, or what we have here already. It's the graph of these two inequalities. All right, let's try some more examples. Example 3 just asks us to get a little bit of practice graphing the following double inequalities, also known as compound inequalities. All right, so we have all the x's greater than 8 and all the x's greater than or equal to 4. Remember, this is the and or the intersection symbol. So let's graph all x's greater than 8, everything to the right of 8, and all the x's greater than or equal to 4. So here are all the x's greater than or equal to 4. Now remember, we want the and or the intersection. Where do these two lines begin to overlap? And it looks like they're going to begin to overlap right here with an open circle at 8 and everything to the right of 8. So we will get rid of the two that we started off with, and we would say the solution to this double inequality would be all these values greater than 8. Let's just take, for example, the number 10. If I put 10 in for x, 10 is greater than 8 and 10 is greater than or equal to 4. However, if we were to take the number 6, for example, let's try 6. 6 is not greater than 8, even though 6 is greater than or equal to 4. That's why we're graphing all of the solutions to the right of 8. That would make the intersection, or both of these inequalities, true. All right, example 3b, we want to graph all the x's less than or equal to 8 and all the x's less than 4. So less than or equal to 8 would be closed circle here and everything to the left, and all the x's less than 4, open circle here, and everything to the left. So because it says and, we want the overlap or the intersection. And that's going to be an open circle here at 4 and everything to the left of 4. So once again, we can kind of get rid of these other ones here. And there is the solution to this double inequality. All right, let's try letter C. We want all x's greater than or equal to 8, or all the x's less than or equal to 4. So remember, with the union symbol, we're graphing both of these inequalities. All x's greater than or equal to 8 is a closed circle here at 8 and everything to the right. All the x's less than or equal to 4 would be here at 4 with a closed circle and to the left. All right, so both of these will combine to be our solution. And we won't draw it again. We're just going to leave them just as they are. All right, I'd like for you to try letter D and letter E on your own. We're going to go down to letter F and G. In letter F, we want all the x's greater than 8 and all the x's less than 4. Remember, this is the overlap. So let's graph the overlap. All the x's greater than 8, open circle here at 8 to the right, and all the x's less than 4. So that's to the left of 4 with an open circle. Now, if we were to merge these two on top of each other, you would see that there is no overlapping here. In other words, there's no intersection. So when it comes to graphing this, there's actually no solution. So when there's no solution, we're just going to leave it as an empty number line. All right, our final little graph of this double inequality. We have all the x's less than 8 or all the x's less than or equal to 4. Remember, this is a union, in which case we're going to graph both of these. So all the x's less than 8 is an open circle to the left of 8, and or all the x's less than or equal to 4. Less than or equal to 4 would be a closed circle here at 4 and an arrow off to the left. Now, if we are going to graph both of these, if we merge them both on top of each other, what this will look like is it will just look like an open circle here at 8 and everything to the left of 8. So our final solution here would look just like this one. All right, let's get into some examples where we may be solving some double inequalities. In example 4, we want to write each sentence as a double or a compound inequality. We have a number C is less than 5 and greater than or equal to -2. So we can just write it out as C is less than 5 and is greater than or equal to -2. We can write it like this. In letter B, we have a number T is less than -1 or greater than or equal to 1/2. So again, we can write this as T is less than -1, or is our union statement, and T is greater than or equal to 1/2. All right, so there's our or statement or our union, and up here we have an and statement. Let's take a look at solving a compound inequality. When it comes to solving these, you're really just going to solve each inequality one at a time, following your rules that you know about solving inequalities. So in this first one, we're just going to highlight the left side of that equation first. We'll solve that, and then we'll solve the right side. So I have -3 less than x plus 1. I'm going to subtract 1 from that -3. That gives me -4 is less than x. Now we're going to just focus on the left, or sorry, I should say the right part of that equation. X plus 1 is less than 5. When we subtract 1 from that positive 5, I'll be left with x is less than 5 minus 1, which is positive 4. Now, when our x is written in between these two inequalities, this is an and statement. This is an overlap. So I want all of my x's that are greater than -4 and all of my x's that are less than positive 4. So this is going to be an open circle here at -4 all the way over here to positive 4 where there's another open circle. All right, let's try example B. Similarly, we are going to solve this one at a time. We're going to add 4 to both sides. I get negative 7 plus 4 is going to give me negative 3. It's less than negative 3w. And now I'm going to divide by negative 3. When I divide by a negative number, remember, you're going to reverse the direction of that inequality. So negative 3 over negative 3 is positive 1. Change the direction of the inequality, and there's my w. All right, now let's focus on solving the right side by adding 4 to that 2. And I'm going to be left with negative 3w is less than or equal to 6. Now when I divide by negative 3, again, I'm going to divide by negative, so I got to change the direction of inequality. It's going to now face away from the w. W is greater than or equal to negative 2. Once again here, you're going to see that this is an AND statement, an overlapping statement. So we're going to have our negative 2, negative 1, 0, 1, 2, and we're going to graph all the w's that are greater than or equal to negative 2. So we have a closed circle here, all the way up to positive 1, in which we're going to have an open circle. All right, we got another example here, and here's where we're going to solve a double inequality with the OR statement. So again, you're just going to solve both of these inequalities and graph the solution, both of those solutions, on a number line. Let's start off by subtracting 6. That gives me 2x is less than negative 8. Divide by 2, and x is less than negative 4. Or, now we're going to add 5 to both sides. We got 4x is greater than 8. Divide that 4 over x is greater than 2. All right, so let's graph our inequalities. Remember that this is an OR statement, or a union, so we're going to graph both of these. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2. I want all of my x's less than negative 4, so open circle here at negative 4 and everything to the left. And then I'm going to graph an open circle here at 2 and everything to the right. So there is the graph of my solution set to this double inequality.